The measure of uncertainty of various phenomena is known as probability. It is defined as the ratio of the number of outcomes. If it has more than one possible outcome and it is not possible to predict the outcome in advance, such an experiment is called as a random experiment. If two coins are tossed simultaneously, the possibilities are head and head, head and tail and tail, and tail and head. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very easiest and important chapter, that is the last chapter, probability. So before going to a definition of a probability and the problems based on probability, the weightage for this chapter is you will get 8 marks, 1 MCQ question from this, and 2 marks 1 question, 2 marker 1 question, and 1 5 marks question. So totally from this you are going to get 8 marks, 5 plus 2 plus 1 MCQ, 1 2 marks question and 1 5 marks question, 8 marks from this. Now today I am going to discuss regarding definition of a probability and a definition of random experiment and a sample space and the simple problems related to random experiment as sample space and a probability. Now let us know what is this probability first. You might have been studied this in your previous classes itself. So probability is nothing but it's a measure of uncertainty of various phenomenon. The measure of uncertainty of various phenomena is known as probability. It is defined as the ratio of the number of outcomes, that is the ratio of total number of outcomes favorable to the total number of outcomes. So it is defined as the ratio of number of outcomes, that is the number of outcomes, the ratio of number of outcomes favorable to the total number of outcomes. Suppose if S is the sample space and A is any event, then the probability of this is denoted as probability of A is equal to N of A divided by N of S. What is A? N of A is a number of favorable event and N of S is a total number of events. So that is, it is the ratio of number of outcomes favorable to the total number of outcomes. The number of outcomes which are favorable to the total number of outcomes ratio is called as the probability. So denoted as N by A is equal to N by S. Suppose if M is a favorable outcomes and N is a number of outcomes, then this is nothing but M by N is the probability of a given event. Now let us know regarding an experiment. Random experiments. What is a random experiment? An experiment is called random experiment if it has more than one possible outcome. So if it has more than one possible outcome, then it is called a random experiment. It is not possible to predict the outcomes in advance. So if it has more than one possible outcome and it is not possible to predict the outcome in advance, such an experiment is called as a random experiment. Now let us consider, for example, if a coin is tossed. So what is the possibility we are going to get? So S is a sample space, either we may get head or tail. So if on tossing a coin, we will get either head or tail. We cannot predict in advance. So therefore, this is an example for a random experiment. Now let us know regarding what is an outcome. A possible result of a random experiment is called an output. Suppose if we toss a coin, tossing a coin, what are the possible outputs? Head and tail. So these are the possible outputs. Suppose if we toss two coins simultaneously, what are the possibilities? So we may get head and head, head and tail, tail and head, tail and tail. So these are the outcomes. This is also called as a sample space, right? So a possible result of a random experiment is called as outcome. So the set of all outcomes of a random experiment is called as the sample space. As I told, if a coin is tossed, what is the possibilities? We are going to get head and tail. So therefore N of S is equal to 2. Similarly, if a coin is tossed 2 times, what is the sample space we are going to get? S is equal to head comma head, head comma tail, tail and head, tail and tail. So therefore here this sample space contains 4 events, right? So set of all outcomes of a random experiment is nothing but an sample space. Now by knowing this, let us take simple problems. One more question. Write the sample space for the following random experiment. Two coins are tossed. If two coins are tossed, what are the possibilities we are going to get? S is equal to head and head, head and tile, tile and head, tile and tile. So number of events is equal to 4. N of S is equal to 4. If two coins are tossed simultaneously, the possibilities are head and head, head and tile, tile and tile, and tile and head. Find the sample space of rolling a pair of dice. A pair of dice. Now, so a die contains, so A is nothing but it contains 1, 2, 3, 4, 5 and 6. Now, if a pair of die is thrown, what is the sample space we are going to get? S is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, we will get 2, 1, 2, 2, etc. Then 2, 6. From this, again, next element is 3, 3, 1, 3, 2, 3, 3. The last one is 3, 6. Similarly, 4, 1, 4, 2, 4, 6. Again, 5, 1, 5, 2, and 5, 6. And the last one is 6, 1, 6, 2, 6, 3, 6, 6. So, these are the sample space when a pair of die is rolled. So, therefore, here N of S is equal to 36. This contains 36. That's it. Okay. Now, move on to the next problem. A coin is tossed and a die is rolled. So, a coin is tossed and a die is rolled. We have to write the sample space for this. Now, suppose if a coin is tossed, let us assume the event A as a coin is tossed. What are the possibilities? We are going to get a head and tile. So, for a die, when a die is thrown, let us consider this as B. So, what are the possibilities? We will get 1, 2, 3, 4, 5 and 6, right? So, 1, 2, 3, 4, 5, 6, a head and a tile. Using this, we have to write the sample space. A coin is tossed and a die is rolled. So, the sample space is S is equal to, so H 1, then H 2, first head 3, H 4, then H 5 and H 6. Similarly, if T is taken, that is tile. So, T 1, T 2, T 3, T 4, T 5 and T 6. This is the sample space. So, this can also be written as S is equal to, if you want, we can also write it as H1, H2, H3, H4, H5, S6 and similarly T1, T2, T3, T4, T5 and T6. This is how we are going to write the sample space. So, next problem, a coin is tossed 3 times. So, if a coin is tossed 3 times, what is the sample space we are going to write? So, if a coin is tossed 1 time, we are going to get 2 events, head or tile. So, if a coin is tossed 3 times, 2 into 2 into 2, that's equal to 8 events we are going to get. So, that is A is equal to head, tile, again head, tile, again head, tile. First, just write down the cross product for these two. That is, what we will get? Head and head, head and head, head and tile, then tile and head, tile and tile into head and tile. Now, just multiply this. What we will get? The sample space will be like this. So, head, head and head, 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 then head, head and tile, head, head and tile. Next, head, tile and head, head, tile and head, then head, tile, head, tile and tile. Next, third one, tile, head and head, then tile, head and tile. Last one, tile, tile and T, T and H, T, 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 T. So this is the sample space. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So n of s is equal to 8. That's it. This is how we are going to write the sample space for the whenever a coin is tossed 3 times. Now, what is the next problem? A coin is tossed 4 times. If a coin is tossed 4 times, what is the possibility we are going to get? So, since this is 2 into 2 into 2 into 2, 2 to the 4, 4 to the 8 to the 16 outcomes we are going to get. The sample space contains 16 events. So, that is, first write down head and tail into head and tail. So, this is nothing but head, 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 tail, tail, head, tail and tail. Again multiply with the head and t. So, this is equal to head, 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 then head, tail, head, tail, head, head, tail, tail, head. Next, with the t, this is h, h, t, h, t, t, again t, h, t, 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 t. Right. So, you just multiply this with again h and t. That's it. Now, the sample space will be like this. So, therefore, s is equal to, just multiply it. So, first take this h, h, h and h, then h, t, h and h, second element, third t, h, h and h, then t, t, h and h, then h, h, t and h, h, t, t and h, again this one t, h, t and h, again t, t, t and h. Now similarly multiply with t, that's it. So that is h, h, t, then h, t, h and t, again t, h, h and t, again t, t, h and t, h, h, t and t, then h, t, t and t, again t, h, t, 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 t and t. That's it. So, this is the sample space. If you count, you will get n of s is equal to 16 events. That's it. This is how we are going to write the sample space for a coin is tossed 4 times. Okay. 2 boys. How many boys? 2 boys and 2 girls are in room X. So, 2 boys and 2 girls are in room X and 1 boy and 3 girls in room Y. So, in room number X, there are 2 boys and 2 girls. In room number Y, there are 1 boy and 3 girls. Specify the sample space for the experiment in which a room is selected and then a person. So, a room is selected and then a person. For this, we have to write the sample space. Okay. Now, let us denote the boys as B1 and B2 and girls as G1 and G2. Let B1, B2, B3 denotes the boys and G1, G2, G3, G4, G5 as or girls. Let us denote B as boys and G as girls, right? Now, therefore, the sample space S is equal to, so in X we have 2 boys and 2 girls. So, therefore, consider this as X into B1, X into B2, X into boy 1, X into boy 2. Similarly, X into girl 1 and X into girl 2, X G1 and X G2, right? And 1 boy and 1 girl in Y. So, that can be written as Y into B3 and Y into G3. Similarly, so only 1 boy in Y, so Y into B3 and how many girls? 3 girls are there. So, Y into G3, Y into G4 and Y into G5. This is how we are going to write the sample space. That's it. Now, move on to the next problem. The next problem is 1 die of red color, 1 of white color and 1 of blue color are placed in a bag. 1 die is selected at random and rolled. Its color and the number on its uppermost face is noted, describe the sample space. See here, one red color, one red and one white and another one is blue color are placed in a bag. So these three different colors of dice are placed in a bag. One die is selected at random. So we are going to select one die and roll. Its colors and the number on its uppermost faces are noted. The color and the number on its uppermost, the color of the die and the number appear on the uppermost face is noted. Describe the sample space of this experiment. So very simple. Let us represent that the red die is denoted as capital R, then white is denoted as W, capital W, and the blue is denoted as capital B. Right. Okay. So therefore the required sample space is S is equal to, first, how many numbers are there in the die? So in die we are going to get 1, 2, 3, 4, 5 and 6. Right. So when a red color is selected, so the possibilities are R1, R2, R3, R4, R5, R6. Similarly, for white, this can be written as W1, W2, W3, W4, W5, W6. And the last one, blue, that is B1, B2, B3, B4, B5 and B6. So these are the sample space. That's it. Okay. Required sample space is R1, R2, R3, then W1, W2, W3 and B4, B5, B6 is the required sample where the color and the number on its uppermost is noted like this. Okay. This is how we are going to solve this problem. Hope you followed. Right. Now move on to the next problem. An experiment consisting of recording boy-girl composition of families with 2 children. An experiment consisting of recording boy-girl composition of families with 2 children. What is the sample space if we are interested in knowing whether it's a boy, girl in order of their births? So what is the sample space? We have to write the sample space if we are interested in knowing whether it's a boy, girl in the order of their births. Second one, what is the sample space if you are interested in number of girls in the family? Right, very simple problem. Just write down the sample space for the first event. Now, let B stands for boy and G stands for girls. Right. Then, so first one, the required sample space S is equal to, what is the sample space if we are interested in knowing whether it is a boy, girl in order of their births, right? So it will be B, B, boy, 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 girl, then girl and boy, girl and girl. That's it. This is the sample space. Now, second, what is the sample space if we are interested in number of girls in the family? The second one is, so if you are interested in the number of girls, so here there may be 0, 1 and 2. That's all. 0, 1 and 2. This is the sample space. Now move on to the next. A box contains one red and 3 identical white balls. A box contains one red and 3 identical white balls. 2 balls are drawn at random in succession without replacement. Write the sample space for this experiment. So without replacement, we are going to write the sample space for this. Let us represent, let R denotes a red and W will denote a white balls. Right. Now what we want to write is the 2 balls are drawn at random in succession without replacement. So therefore the sample space will be S is equal to, right, red and white, R and W, then white and red, W and R, and W and W. So this can also be written as S is equal to R, W, W, R and W, W. This is the sample space. So it contains 3 events. N of S is equal to 3. That's it. Now move on to the next problem. Suppose 3 bulbs. How many bulbs? 3 bulbs. 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective or not defective. D means defective, N means not defective. Write the sample space for this experiment. So, suppose 3 bulbs are selected at random from a lot of bulb which is tested and classified as defective D and non-defective N. So, we have to write the sample space for this experiment. Okay. So, what is the possibility? Therefore, the sample space is equal to how many bulbs? 3 bulbs. Suppose if all the 3 bulbs are defective, this can be written as D. Okay. Next, first 2 are defective and third one is not defective, D and N. Now, first is defective, not defective and defective, D and D. First one is not defective and second and third are defective, N, D. If all the 3 are not defective, N. Next, N, D. First 2 are defective and third one is not defective. Then N, D, N. And the last, defective, not defective. This is the sample space. See, 1, 2, 3, 4, 5, 6, 7, 8 events we have. So, 3 bulbs are selected at random from a lot. Each is tested and classified as defective or non-defective. The sample space will be first 2 are defective, second one is not defective. First one is defective, second one is not defective, third one is defective. First one is not defective, second and third are defective. All the 3 are non-defective bulbs, that is non-defective, N. And first 2 are non-defective, third one is defective, N, and the last one defective, non-defective. This is the sample space. So, here N of S, this contains, that is 8. 2 into 2 into 2, 2 to the 4 to the 8, that's it. Okay. So, that's all regarding this problem. Hope you followed this, right? These are few problems for 1 or 2 marks. Hope you followed. So, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.